We got an astronaut helping us who's determined. Oh, look at all this. Okay, we're going to do one more grouped frequency distribution. This happens to be the wins for a particular season. Not sure why we're not told which season it is, for all the Major League Baseball teams. And we're going to create a grouped frequency distribution. And we're going to follow those steps we were shown before. I'm going to do this in Excel. So the first thing we need to do is take our data set and sort it from smallest to largest and calculate the width of our classes. So what I'm going to do is I'm going to take the largest number in the data set, which happens to be 116, subtract from it the smallest number, and we're going to decide how many classes we need. Now I'm seeing 28 classes or 28 data values, so I think a set of 5 is going to be a good number here, 5 classes. I don't think we want to do too many more, because if we do more than that, we're not going to have much to see from our classes. Note that the width is going to be 5 on this. So I'll come over here, I'll type in the fact that we're only going to generate 5 classes. We'll start with our lower limit. I'm just going to use 92 as the minimum. And then I'm going to add to that the 5, which is our width between each class. And we're going to get our 5 lower limits. And then remember, we're going to add one more to get our next dummy lower class limit. And to get our upper class limit, we're going to take the next lower limit, subtract 1 from it to get our upper limit. There's all of our upper limits for our 5 classes. And now we're ready to do our counts. So we're counting how many Major League Baseball teams had wins from 92 to 96. I see 4 in there. How many got between 97 and 101? So I'm seeing here a count of 7. How many got between 102 and 106? There we go. I'm seeing a count of 8. How many between 107 and 111? So I'm seeing a count of 7 again. And then I saw only 2 left at the end. Let's just check what was our sum here. How many Major League Baseball teams did we add up here in our frequency, grouped frequency distribution? We got 28. Looks like we're missing 2. Okay, so I went back and retyped my data set and noticed that I did indeed make a mistake. Somehow I typed in the wrong data values. Oops, and I made a mistake again. That should be 107. So I've resorted. The cool thing about Excel is, let's see. It's the same thing, like my width isn't messed up. All I have to do is redo my counts. So 92 to 96, I still got 4. 97 to 101, I now have a count of 7. Oh, that's the same. Okay, 102 to 106, that count is 9. Oh, there's my 2 missing ones. Okay, now I fixed my mistake. I'm ready to go. This is our frequency distribution for the number of wins for a particular season of Major League Baseball. Now, this is supposedly a nicer view of things, but we can also turn this into a graph, and that graph is called a histogram. So let me show you where I'm getting that from our notes. It's very similar to a bar graph, where the heights of the bars are frequencies. The difference is that the widths of the histogram have meaning and that they need to be touching. And so what we're going to do is, what I'm going to do is draw a histogram of this data set. So what happens is, let's see, I'm going to use my Excel thing here as my drawing, and I'm going to do the best I can here, y'all. So my minimum value is 92. Now, one way to fix this to show that we're not including 0 is to use a little break. And this is going to be 92. And then we're going to put in 97 and then 102. Notice the pattern here. I'm putting in the lower limits as my tick marks on this x-axis. My y-axis then is going to be the frequencies, and we're going to draw bars that have the heights of these numbers. So from 92 to 97, that's a width of 5, right? And that's the same thing as the class width of all these. And let's see, we go up to a 9. I'm going to do heights of steps of 2 for each of these. 2, 4, 6, 8, 10. So 92 to 97 had a height of 4. 97 to 102, really 101, has a height of 7. So that's like halfway between here. Notice I'm making sure these bars touch. 102 to 107, which is really 106, we have a height of 8. And then 9 for the 107 to 112. So that's halfway in between here. Shoop, shoop. And then 112 would have gone up to 117 for that last one. That has a height of 2. Shoop. And then really we should be filling these in. Like I should be shading this. And this is our histogram. And another nice thing, like back from section 1.3, we really should be labeling these bars. We've got the picture, but we should also put in the quantitative data, right? This is 4, this is 7, this is 8, this is 9, and this is 2. And there's our histogram. We also need to label things. This is wins for MLB season, and that's the frequency, that's the number of wins for that season. Now our author gives us another one what we can use, asks us to take the temperatures for the highs and lows of that we did in the previous video and make a histogram out of that. So let me hop back to Excel and show you that data set. Remember, this was our lower limits of 100 up to 135, and then we're going to turn this into a frequency distribution right there on the page. So for this, we would start again. I need to show a gap here. We're not allowed to by how he's printed it in the textbook. So we're just going to start at 100, and then we're going to 105 and 110, 115, 120, 125, 130. I guess I could have set a gap here. 135. These bars, we need a maximum of 16. So what? 2, 4, 6, 8, 10, 12, 14, 16. Okay, so we can do steps of 2. And then let's draw our heights. This first one would look like this. The next one would be 8. 2, 4, 6, 8. Shade that one in. 110 to 114 had 16 in it. That was our highest one. $115 to 120, that has 13. Let's see, this would be 14. So 13 is halfway in between there. 120 to 125 is at a 7. So if this is an 8, we're halfway in between here. $125 to 130, we are only at 2. So it's right here. Shoop. And then 1 at the 130 to 134. So again, this is just a picture of our grouped frequency distribution. And I think many would argue that this is easier to read than our grouped frequency distribution, because at a quick glance we can kind of see how our numbers are laid out.